Today I want to talk about noise. It's a field that I have many years of direct experience in. We're going to talk about how to understand your particular problem, the level of noise, where it's coming from, what you might do to stop it using noise barriers, using noise absorbers, possibly masking the sound, often incorrectly referred to as white noise. I'll touch on noise cancellation probably. But anyway, let's get started here. First off, this is not a lunch and learn session, which means I will teach you a little bit about this field, but I'm not going to feed you at the same time. I used to deal with engineering firms, particularly mechanical engineers, architectural firms, and different companies involved that had equipment that had high levels of noise issues, such as Train Carrier York, the big industrial air conditioning people. And they like to ask me to come in and buy them lunch and give a presentation, and they would learn and I would get to pay for their lunch. I quickly learned that that was not a profitable situation. So I stopped that and just called on them when they had specific issues to deal with. So therefore, if you need to take a break and go grab something to snack on, you can do that now before we proceed. The first important step is to define the problem, and that will require you to take a piece of paper and draw a sketch of your particular situation. What is the noise source? And if there are more, obviously you include them all, but we'll deal with one at a time initially in solving the problem. What is the decibel level? Generally it's measured at 3 feet from the offending piece of equipment or whatever it might be. Are there reflective surfaces? Is it a direct line of sight? Is it uphill from you, downhill from you? Are there other obstructions, reflective surfaces, that sort of thing? You'll also measure it at the position that where you are when you're being offended by the noise, generally. What is the acceptable level? Here's a couple of charts that show you some basic levels of noise from different sources. If the decibel level at your location you're hearing is the offending is 80 decibels, for instance, and you want to get to 60 or 50, you know that you have to design a solution that will decrease the decibels by 20 or 30 decibels. And first we need to measure the decibels. Oh, here's an example of a sound level meter that you can buy for about $100 US or sometimes less. Or you can spend thousands of dollars on equipment software like I had to do to get more precise measurements at frequency levels also. Or you can download an app for your phone. The one that I use is called the Physics Toolbox Suite, I believe. And it has, I think, about 13 different apps, including light meter, sound meter, and all those types of things. But just do a search for a sound level meter, and you'll have several options there. This particular app that I'm using has a compass and just a bunch of fun apps to use, and they're very, very quick to respond to comments or issues that you have. This app gives me a decibel level. Up in the upper left-hand corner, it gives me the decibel level. And it also does a charting. You can save that charting if you want, download it to your computer, if that's something that you want to do also. There are a number of factors that will affect your readings that you need to take into account. Wind would be a major one, atmospheric pressure, moisture in the air, humidity, those types of things. If the wind is blowing towards you, blowing the noise towards you, normally, if there's a crosswind, normally, if the wind is blowing against, away from you towards the sound, usually, it would be best to measure it on those days. when you have the most noise issue. I know when I was growing up, sometimes at night, I could hear traffic on a highway a mile and a half away. Other nights I could never hear it. And I always suspected it had to do with atmospheric conditions, but I was never quite sure. But that would be the case. If you take your measurements when the wind is blowing blowing the sound away from you, and then you design your solution around that, you'll be disappointed when the wind changes the way it would more frequently be, and you get more of the noise. Katabatic wind is just one example. Here it shows the wind action, the moisture, that type of thing. Also, if equipment is the issue, you want to take measurements on the various sides, because each side of equipment will have different decibel readings, different frequencies oftentimes. If it is a chicken or a dog that is the issue, it may take some time for you to chase that particular animal around to get the readings from the front, the rear, and both sides. I highly recommend that you be careful as you do that. dB stands for decibel, and when you see the designation dBA, the A is a designation for how the average human ear hears sound. There are several ways that we measure it. dBA is an approximation of how humans read that. Most meters will allow you to set it to the dBA designation. Also, whether you want to have full decibel levels or third octaves. Now, let's say that this is the noise source that's bothering you. You want to measure the decibel level near that noise source, and then you want to measure the noise level at the position you are where it's annoying you. It's often easiest to deal with the noise at the source, to block the noise, to absorb the noise, to reflect the noise some other direction. In this case, it looks like that's probably, he's got an enclosure there with a gate and for access. It looks like that may be mineral wool on the inside to help absorb the noise so it doesn't reflect. Behind the mineral wool, I certainly would expect there to be some type of barrier, very possibly a what's called a mass-loaded vinyl. It's about 1/8 inch thick. It's vinyl, and it's mass-loaded to make it more dense. It's limp and it's dense. They used to use, back in the old days, they used lead. We no longer use lead. Barium salt has been used. There are some companies that use some other things to make it dense and limp. Here's an example of mass-loaded vinyl. Usually comes in a roll, or you can get it in sheet form. It's usually 1 pound per square foot is how it's usually designated. You can get half pound. I would not recommend it. You can get 2 pound per square foot mass-loaded vinyl, which, especially if you're dealing with lower frequencies, that would be highly recommended. There's a company in the USA called Acoutiblok. Acoutiblok, Acoustiblock. They probably make the highest quality mass-loaded vinyl on the market today. There is a company out of Australia called Acoustica, acoustica.com. He actually does a lot of work for the Australian Navy in soundproofing the ships. And they've got a very unique product line. I dealt with them a little bit many years ago, and it just didn't seem feasible to import all the way from Australia. There are dozens of companies that can supply you with mass-loaded vinyl, and many of them will also supply you with a rail system like this here, where you can hang it so you can slide it out of the way for access to equipment, those types of things. Mass-loaded vinyl noise barrier is often sewn into a quilted type pattern like this. and it oftentimes has sound absorbing fiberglass matting on either one or both sides of it to reduce the reflected noise also. And you can have windows, for instance, probably a clear vinyl window sewn in there also. Just another example, but oftentimes you want to incorporate absorptive materials in with your mass-loaded vinyl or whatever other material you're going to use to block the noise. Perforated metal panels, 2 inches thick. I always used 4-inch thick panels. Often use them for exterior applications. With a barrier on one side normally, and then that area, that 2-inch, 4-inch area, is filled with acoustic fiberglass or mineral wool generally. There are other products you can use also. The perf pattern is important so that it's acoustically invisible to sound, so that the sound gets into the absorptive materials. And right off the top of my head, I don't remember the proper size and dimensions of those. Many different materials and thicknesses of materials have been given what's called NRC, Noise Reduction Coefficient, or STC, sound transmission class numbers, to give you some idea of how much noise a particular product can stop or how much it will absorb. And I will get to some of that information shortly. This little diagram gives you an idea of several different types of materials and what decibel level you could expect to get by using them. Now, there are many other factors involved in that, including wind, including height. STC, or sound transmission class, is a designation that we often use to show how well a product blocks noise. So it's important to know that if you're designing a system to block a certain amount of noise, to bring a certain amount of decibels down, it's important to know the STC rating of the materials that you're going to use. NRC, or Noise Reduction Coefficient, is the designation we usually use to classify materials about how well they absorb sound. And we also break that down, both the barrier and the noise absorbing materials, we break them down in how well they do that at various frequencies. Some materials will block or absorb very well at some frequencies and not well at all at other frequencies. So that's another reason why it's important to know what frequencies you're dealing with. The lower frequencies in general are more difficult to block and to absorb, to deal with those. It requires more dense materials, different types of materials oftentimes. One strange thing about NRC is oftentimes a material at certain frequencies will show a valuation of greater than 1. 1 is perfect absorption, but you might get a 1.1 in certain frequencies. So it's not perfect, but it is what we use at the present time to give us an idea of the values. Knowing the frequency that you're dealing with is often important. As I said, many materials work better at different frequencies than other frequencies, lower frequencies being harder to deal with usually. If you're dealing with equipment, many manufacturers have that information online, what frequencies their equipment operates at, the sound that they put out. You can find just about anything online anymore. If you can't, this physics toolbox that I use, it has a pitch detector. I'm not sure how accurate it is. Here's a quick example of what it does. So here it's, I got it up by my air conditioning unit. It's not picking up much at all there. I'm going to show you a few examples of blocking and absorbing noise at the source. If a piece of equipment, for instance, is liquid cooled or heat buildup is not an issue, we can often use something like this, which is a custom-made noise blanket. And it is made on the inside. You'll find usually the mass-loaded vinyl, and then some absorptive material, quite often the acoustic fiberglass mat sewed together. And we custom make those in panels, and then they just, in installing them, they all tie together real tight. And you can often reduce the noise of an item 3 to 5 decibels, or even up to 7 decibels with something like that. 3 decibels is generally the human ear can tell the difference, but it's not going to make that much difference. You usually want to get up closer, up above 5 decibel reduction on something like that, and preferably even up to 10 and above, depending upon how loud it is. This is a large barrier wall. It could be a combination barrier absorber. For instance, you're going to, if it's a barrier, you're going to be reflecting that sound back to our right here. And there may be another, probably is a building there, where you would then get reflected sound going back the other direction. So if you add absorbing material in there also, you'll get less reflected noise. Or you put absorbing materials on the building, the other reflective surface. This could be a dog pound, it could be a shooting range, it could be other types of equipment, it could be small, it could be large. You can scale it to your situation, use your imagination. And many different types of materials could be used for this, but you just need to design it to get the reduction in decibels that you want. Most manufacturers and distributors of noise control materials are smart enough and have the software and the information necessary to help you design for the decibel reduction that you want to achieve with your particular situation. Whether it's an outdoor application, indoor application, a media room where you want to change the sound from your sound system. Now, if you're putting up a wall near equipment that is air-cooled, you have to take in consideration what type of airflow that unit needs to achieve its cooling. Most of the big air conditioning chiller situations that I was involved in, they preferred to have 4 foot around all the units, but they normally would allow us 3 foot for the air circulation and the big fans that come up out of the top of there for the cooling without affecting the warranty of the operation. Here we have an example of 2 things. We've got the noise source apparently is a industrial chiller, Train, York, Carrier, there's McQuay, there are a couple other manufacturers. And I'm guessing that there's a couple things here. The noise source is bothering residents on the other side of the wall to the left there. So they built the noise barrier wall, and hopefully it has some absorptive properties also. I can't really tell from here, possibly not. On the right side, on the building itself, those appear to be perforated metal panels set at fairly close distances to each other to absorb the reflected sound. Otherwise, that noise would reflect off the building, over the fence, and continue to bother the neighbors. It's also going to help with the vibration and the sound going into the building itself, probably to some degree. And I'm very certain those are perforated metal panels that have probably acoustic fiberglass mat on the inside, or possibly mineral wool sometimes is used. It's always good to have a goal when you start a project like this. We deal in decibel A generally, but there's some guidelines that will help you set a goal. We deal with sound power, and we deal with sound pressure. Sound power is like equivalent of a light bulb, the power of 100 watt or a 50 watt. It's the amount of sound at the source. Sound pressure, you factor in the distance also, and how it drops over distance. For instance, if you've got a light bulb, 10 feet away, it's a certain brightness. 50 feet away, it's a certain brightness. Same thing with sound pressure. A couple rules of thumb is that if you decrease the sound by 10 decibels, that is half the perceived loudness for most people. So if you want to reduce the noise by, if you want 1/4 of the noise that you're now hearing, that is a 20 decibel reduction. Now I've given you a basic introduction to dealing with noise at the source. I want to cover several different things here. Sound masking, in particular, often called white noise. I want to cover that. There's also pink noise, there's red noise, and there's brown noise. Brown noise does not have anything to do with flatulence, fortunately. I can see that this subject is going to cover probably 3 or 4 different videos. I want to cover a number of things, including soundproofing or reducing the noise within your home, your apartment, your condo, using sound absorbing materials, using sound barrier materials, the different procedures that we can do. Walls, windows, ceilings, floors, doors, media room, a little bit about schools, a little bit about laws, and Hollywood, what they do to block off the noise from areas that they deal with. But I want to touch on many different subjects. But let me get back to white noise, sound masking. There are systems, big and small systems. There's even a system desk, basically something you sit on your desk, and it puts out a couple speakers that you can mount above your desk, and it puts out the white noise to help mask or cover the annoying noise. Basically, white noise is you're just covering the noise that's annoying you. Oftentimes done for privacy issues in office settings, but I'm sure you've all done that. You've run a fan, you've run your stereo, you've run the television to help block out other annoying noises. I do it all the time. For 2 hours when I go to bed, I turn my air conditioner on, and that blocks out a lot of the noise that goes on from about 11 o'clock to 12:30 in the morning where I'm at. Or you turn on, you can download apps to your phone or your laptop, your tablet, white noise, and you can type in different types of noises that you want to listen to, running water, falling rain, various different things to help mask the other noises that are bothering you. One thing I often do is I go to a YouTube channel called Acoutiblok. He's an expat, lives up in Luzon, and he puts out a lot of relaxing music videos, and I can turn that on and have that run for some hours, and it's relaxing. A lot of it's jazz type music, a couple different type of genres, and that helps me to sleep. You can check him out on YouTube. Here's a list of some of the manufacturers of sound masking systems. I dealt with Cambridge Sound Management primarily, And they actually make a desktop system. You got a little controller on your desk. You put the speakers up above your different places in your office, and you can adjust the volume. And it was relatively inexpensive, I think. I don't remember, a couple $100 maybe. But anyway, one job I quoted was Las Vegas Caesar's Palace. They had a large office area with about 30 people working in there, and there was a big issue with privacy. Everybody could understand the people near them, their discussions, and they wanted to put sound masking in there to provide privacy. Unfortunately, that was in 2008 when the economy went to crap in the USA, and everything went on hold, even in Las Vegas. Sound masking done right reduces the percent of sentences, the words that people sitting close to you can understand, and does a pretty good job at that. In the next video, I'm going to discuss how to treat your house, your office, your home, your condo, your factory, whatever it might be, how to treat those areas with sound reducing materials, whether it be using barriers, using sound absorbing materials, windows, doors, ceilings, floors. I'm going to cover all those types of things. Caulking, green glue, special acoustic treatment for various situations, without getting into fully covering your walls with foam, absorptive foam. You can actually make a room too dead to sound, so that would be a very uncomfortable situation also. Here's a question for you to think about until next time. What do these four things have in common? The plate, the dishwashing sponge, the mass-loaded vinyl, and dog food. Could be cat food also. What do they have in common? And I'll answer that next time. Thank you for watching. Please subscribe, like, and share, and hopefully we'll see you next time. See ya.